Okay, now the last part of the lesson is about working out post-exam question. Maintenant, comme on expliquait tout à l'heure, dans post-exam question, you're going to be given a table with all the inputs and their binary value and their corresponding condition. Ensuite, he's going to explain how the system works. Alors, dans ce cas, so we have our three inputs with their binary values and their condition. I am going to use this table to convert this description into their binary value. Alors, comment on va faire? So, alarm will sound when pressure is greater than 80. Now, this is a condition. Pressure is greater than 80. Ça, c'est une condition. Sa condition-là, nous sommes capables de convertir en ce corresponding binary value. So, here you have pressure is greater than 80. And the corresponding value is P is equal to 1. Right. So, I am going to convert the condition into its corresponding value. So, where P is 1, we get pressure greater than 80. So, we have, then you have AND. Oubliez que le mot AND est codé en gate. So, on circle the temperature is greater than 35 degrees Celsius. So, this is a condition again. I am going to look for the condition. So, here it is. This is the condition. So, this condition happens when T is set to 0. Alors, on met ensemble, on met les en ce corresponding binary value. Here again, you have 0 for the input T, which gives the temperature greater than 35 degrees Celsius. O is a gate. On circle. Ok. C'est qui mot qui joint une phrase. Normalement, c'est une bonne gate. Ici, il y a temperature less than 35. So, I'm going to look for temperature less than 35. Here it is. So, it is a state where the input T is equal to 1. You get that. Temperature less than 35. Alors, ça, I'm going to, the T is equal to 1. Next, this is N, so it is going to be the N gate. The pH is greater than 7. Marcia, pH greater than 7, so here it is. So, pH is greater than 7 when A is equal to 1. Alors, pH greater than 7. On change ça, on fait ça ici. A is equal to 1. Okay, almost there. Alors, mon nouveau description maintenant, on va mettre en termes description, mettre en termes binary value. So, it is going to be alarm is equal to 1 if oubliez the word the, you don't need to write the, ok, parce qu'il ne peut être écrit en forme de and formule. So, P is equal to 1 and T is equal to 0. Rather, I will write it in capital letter. T is equal to 0 or T is equal to 1 and A is equal to 1. Now next step, c'est que nous allons faire avec ça. If you have all the input equal to 1, you can remove it, but if you have an input that is equal to 0, then you have to change it to not 1. Okay, so I remove this 0. I would rather put not 1 because I leave in not 1. Okay, now I can remove. So I have a NOT gate here. I have an AND gate, OR gate, AND gate. Right? Alors, mon retire ça is equal to 1 là. Mon retire ça is equal to 1 là. Mon retire ça is equal to 1 là. Mon retire 1. So the expression will be alarm is equal to P and so this is T not equal to 1, so it is going to be not T. Then I have O and the second line is C, so it is going to be T and A. Right. Okay, now I have to build or draw the circuit diagram from my expression. Alors, comment moi t'expliquer? I am going to use my exercise book here. Alors, moi comme expression P and not T O T and A. Alors ici, the main gate is the OR gate ici. Il sépare deux expressions. Just like we have explained in earlier videos. So I am going to draw my OR gate here, toujours à l'extrême droite. So this is the output alarm. Maybe it is, no, c'est pas A. It is alarm. On one side, I have the expression on this line that goes to the OR gate, say P and not T. And on this line, I have the expression T and A. Now, given that this is an expression, le besoin continue casser. Alors, dans ce cas-là, on a AND gate au milieu P avec notre T. Alors, pour faire ça, une AND gate ici. So on one side I will have P, on the other side I will have not T. So this is P and this is not T. Now again, this is an expression. So I have a NOT gate and I have the input T. Now this is an input, on arrête là même. De l'autre côté maintenant, T and A, this is an expression. In this expression you have the AND gate. On one side you have the input T, on the other side you have the input A. Alors, on casse on deux input T and A, so I am going to have my logic gate, my gate AND. On one side I will have T, on the other side I will have A. Now you cannot have two lines producing the input T. Alors, this is the input T feeding onto that NOT gate and feeding onto that AND gate, and this is A, and this is B, and this is voilà. So basically, maybe you will not use all the conditions. Voyez, ça dépend qui condition qu'il mettez ici. Ensuite, you build that expression, and then you remove the equal to 1. You will get your expression. Then from the expression, you can build your logic gate. Voilà.